right, so what we're talking about today is percent composition. And so I had about 100 words to type on here, and I already managed to make a typo. So the definition for percent composition is the percent by mass. This if should say of each element in a compound. And so we have a very simple equation for this. If we want to figure out how much of an element makes up a compound, what we write is the mass of element over the mass of compound. And lastly, we just multiply whatever we get as our decimal by 100. So we're gonna just jump right into examples. There's kind of 3 different ways we can calculate percent composition, and the first of which is being from having data that involves the mass of these compounds and elements. So if we have a 13.60 gram sample of some compound that contains magnesium and oxygen, and we know when we decompose this compound, we find out that 5.40 grams of this is the oxygen. What's the percent composition of this compound? Well, if we think of our formula, we have to make sure that we put the mass or percent comp. I'm going to abbreviate this composition. We're going to break this thing down into oxygen and magnesium, the 2 elements that make it up. So the percent composition of oxygen is going to be equal to the mass of oxygen divided by the mass of the compound times 100. What did the problem tell us that our mass of oxygen was? 5.40 grams. What was the mass of our compound? 13.60 grams. We multiply that by 100, we get 39.7% oxygen. Now, the only other thing that's in this compound is magnesium. So how much? What should be the percent of magnesium then? 60.3. So when we're thinking about what a percent means, we want these things to add up to 100%. If we have 2 things, one of which is 39.7%, then our composition of magnesium would be 100% minus 39.7%, which equals 60.3% magnesium. So these ones aren't too bad. Any questions? Yeah. Yeah. Because so if you think about sig figs, 5.40 has 3 sig figs. So I also kept 3 sig figs throughout this. But good question. Yeah, Leo.
Mine's going up quick, sorry. I got percent. Thank you very much.
Yep. All right. Who remembers the formula for propane? Yeah, C3H8. So this is what we're working with. Now, we can figure out percent composition just from one's formula. So how do you think we figure out the mass of C3H8? What do you think we calculate? You add it up, you find the molar mass. So the first step here is finding the molar mass of C3H8. You guys should know how to do that. Go ahead and figure that out. Go ahead and shout it out when you get an answer for molar mass. 44, awesome. Okay, so if we're calculating the molar mass of C3H8, we have 3 carbons, which each have a mass of 12. We have 8 hydrogens, which each have a mass of 1. That gives us 36 for carbon, 8 for hydrogen. If we add those together, you should have gotten a molar mass of 44.0 grams per mole. Now, when we're figuring out the percent composition for both, I want you guys to set it up with the formal equation for both. Yes, I showed you guys how to figure it out using subtraction from 100%, but I'll show you what I mean. I want you to set up both percent compositions here. So first I'm gonna do the percent comp of carbon. So what's our total mass of compound? What did we just figure out?
44.
Yep, so our total mass of our compound goes on the bottom. That's 44.0 grams per mole. Now, if we're figuring out the percent composition of carbon, we have to put carbon's total mass on the top. What's the total mass of carbons? 36. So we do 36.0 divided by 44 times 100. That gives us 81.8% carbon by mass. Okay. Now, we have to do this for hydrogen as well. I'm going to write it out again just because if we have, I'll move some stuff around here. Oh, that was a mess. Okay, so for hydrogen now, I'm gonna write it kind of smaller down here because I didn't leave myself space. Which one of these two numbers stays the same? The 44 or the bottom number. So we're still dividing by 44.0 grams per mole, but what's our new top number? What's the mass of H? 8. Multiply that by 100. We get 18.2% H. Any questions about the second problem here? Yes, because we need to know how much carbon makes it up and how much hydrogen makes it up. It's the percent composition of both the elements in the compound. Yeah, all right. That is a good check. I said that he sees it equals 100. That's good. Okay. Now, this last one here is not necessarily harder. It's just weirder. So we're going to figure out the percent of mass of water in what's called a hydrate. So if you guys remember, we talked about ionic compounds, nickel nitrate, NiNO32. Nickel nitrate is an ionic compound, which means its structure is a crystal lattice, which looks something like this. You notice how there's a lot of space in between the atoms? Water gets trapped in there. It's not chemically bonded. It just is small enough where it can fit in between the atoms and kind of just gets stuck in there. So the way we represent when water can get stuck in there is dots and then a number H2O. It depends on how much water gets stuck in there. We call these things a hydrate. Yeah. Not necessarily. It's just saying that 6 moles of waters are attached to this nickel. Pretty much what it's representing. Physically, not chemically bonded. And so what we do with hydrates, we can figure out how much water should be there and how much actually is. It's your lab tomorrow. So you guys are doing the lab, figure out how much water is actually stuck inside an ionic compound. And so we're going to figure out how much mass by percent of mass theoretically should be in this. So same idea, we have to figure out the total mass of this hydrate. So to figure out the molar mass of NiNO3 to 6H2O, what I find the easiest to be is break this down into the 2 parts, the ionic compound and the water. So I'm going to first figure out the mass of nickel nitrate. So we have to add up the nickels, the nitrogens, the oxygens. How many nickels? How many nitrogens? How many oxygens? Awesome. Nickel weighs 58.7. Nitrogen is 14.0. Oxygen is 16.0. So we get 58. What? For nitrogen? Yes. And then 96. So if I add these up, from nickel nitrate, we get 182.7 grams per mole. Now I'm going to add up the mass that comes from the 6 water. So we have to incorporate the fact that there is 6 moles of water. So we have to distribute this 6 just like we would if we were balancing reactions. So how many hydrogens do we have then? 12. How many oxygens? 6. Awesome. So 12 times 1 is 12. 6 times 16 is 96. Add these things up together, we get 108 grams per mole from the waters. Okay, so the total molar mass of nickel nitrate hexahydrate is the 182.7 plus the 108 from the water. That gives you 290.7 grams per mole. So that was just figuring out the mass of our compound. So these questions, they only ask about the mass of the water. So we only have to do 1% calculation. So we're looking at the percent composition of water. Where does the number that we just calculated go? On the top or bottom? Awesome, bottom, because that is the mass of the whole compound. And then what number are we putting at the top? 108, water's mass, awesome. 108.0 grams per mole, multiply that by 100, we get 37.15% H2O. Any questions about that? All right. So the plan for the rest of